A very good evening. My name is Darren Gong, and today I will be presenting my programming project. So before I hop into the concept that I implemented in this game, let me go through how my game works. Let me click the start button. So when user start to play it will display a storyline for user. With the horror sound effect, it will give a heart racing feeling when user read the story. This storyline, user can next, previous, or quick. If user want to see the next storyline, just click N and it will show the next storyline. If user want to see the previous storyline, just click P and you will return to the previous storyline. If user doesn't want to read the storyline anymore, you can just it will quit. And after the storyline sound effect, it will proceed to another sound effect for when user start playing the game. So when a player start playing, a player can't directly start a new game because if you play the game directly, you just display please create a player before starting the game. If I create a player, I name it my name Darren, and user can play the game right, start the new game. And user will be blindly choosing a weapon which has 1, 2, 3 numbering, which represent a weapon, but we will not review for the user because we want to make it more interesting. So let's say if I choose the number 2, I will get an X with attack power 2. And next, I will be choosing my survival skill, which is Molotov Cocktail, Frost Bomb, and Adrenaline Injection. For a Molotov Cocktail, it will be dealing a area splash damage of 50, and Frost Bomb will be dealing a least amount of area damage, but it will reduce the attack power of the zombies. While Adrenaline Injection will be doubling the player attack damage. So if I choose the first one, I will be direct to the game information. As for the game information, it will display the zombie health and attack power of each of these 3 zombies. So after the stage clear, it will be proceed to another harder stage where the health and attack power of zombie and boss will be increased. So let's say if I use a skill attack, the zombie health will be deducted by 50, which is 50, 20, 20, and 10. And the third zombie will not dead because it still have the 10 remaining health. But let's say if I wanted to use a normal attack from first action, I can just undo, and the zombie health will be revert back to the original. For my first attack, I want to use a normal attack, and the normal attack will come with sound effect, which is the X attack, and different weapon will have different sound effect. So after I clear this zombie wave, I will start seeing the boss information, the storyline. Here there will be a jump scare sound effect, which when a powerful boss is appeared, then the jump scare sound effect of the thunderstorm will trigger. So once the sound effect is triggered, the boss information will be displayed also, which is a boss name, boss health, boss attack power, and boss rampage power, which is related to the depleting source. So let's say after you attack the boss 3 rounds, and it will enter a rampage mode, which you are given 3 rounds before the boss kill you in 1 blow. So let's say if I do a normal attack, the boss will not deliver devastating blow because it's dead and the rampage round has not reached, so I will not be killed. So after the stage is clear, I will be directed to a stage clear statement where it will start to ask, do you want to change your skill? If I said yes, and I hit Frost Bomb, then my skill will be changed to Frost Bomb, and Every time after the stage is clear, every player can choose their own item. So every stages cleared, player can choose their own item like double damage potion, invincible clock, and a healing potion. So if I choose number 2, I will be getting invisible clock, and the next thing that will appear is door 1 and door 2, which is randomly. If you choose the door 1, you might need to attack the zombie first, then you proceed to the boss. But if you are lucky, you will get to the boss first, which is more better because you don't have to suffer so much damage from the zombie attack. So let's say, if I want to try my luck, I can just put any number 1 or 2. For example, if I put 1, then I will be playing with the zombie first before I proceed to the boss. Just now, I've hidden my invisible clock. So after I prompt number 3, then it will display my inventory. One with value no, which means the skill means the item, not inside the inventory. The one with the yes means that the item is inventory. For example, if when I try to prompt number 2, then my invisible clock will be used and you will declare a message for you are unsuccessful for this round. Let's say if I try to attack the zombies, I will deal damage to them, but my health will not be up. Other than that, let me demonstrate how other skill is used and how other items is used for my game. Now I will choose Frostbomb for my. When I use the skill, the damage of the zombie will be healed by 20 of material damage, which is 20 and 10 for the second zombie, and your attack power will be decreased 5. So for my last skill, it will be an adrenaline injection where user uses the skill and its damage will be doubled by 2. So for example, when I use the skill, you can see that the damage of me initially is 25, it will double up to 50, and it will deal a single damage to each zombie once at a time. So that's how all my skill works, and now I will proceed to the other 2 items in my game. So just now I've demonstrated invisible clock. Let me demonstrate the other 2 items, which are double damage potion and healing potion. So I will try with double damage potion first. As you can see here, this is my original attack power. So once I use the item, my power will be increased by 70, which initially is 35 times 2 is 70. So that's how my double damage potion works. So just now I've demonstrated double damage potion, and last item will be healing potion, where it will heal your HP to your maximum HP, which is 150. So just prompt number 3, and I will get healing potion added to my inventory. Just the 1. As you can see here, this is my previous HP, which is inflicted by the boss and zombies. So if I want to use my item, I just click number 3 and potion. You can see that my health is adjusted to 150, which is the maximum health. So that's how all my item function. So before I hop into my concept presentation, let me demonstrate the last function, which is the save state function for my game, where you will save the whole game into a .dat file. So after I attack the zombie, I can just press number 5, which is save and quit game, and 6 is quit the game without saving. So after I save the game, and I want to retrieve it back, I can just press log save game, which is number 3. And all the information of the previously game will be printed here. So that's all for my game demonstration, and now I will be presenting my concept. So after I demonstrate my program, how it plays, let me hop into the concept that I will be covering in my program. So I will not be using Studio Visual to present because it's very complicated, and I will be using my report screenshot to present the code. So now I'll be continue with inheritance and derived class, which is part of object-oriented programming. So for my base class, I use health, attack power, and name, which will be inherited by the player, zombie, and boss. For player, it will inherit the value of the health, attack power, and name, same as zombie and boss. Next concept I will be covering for OOP is polymorphism. So for polymorphism, I implement an attack function, which is a pure virtual function in character class, consists of character target, which may be player, zombie, or boss, and the number of the zombies and the boss boolean if it's appear or not. So for player attack, it will loop through every zombie and attack the zombie with the player damage. If the boss is not appear, then it will print out each zombie and hit with how many attack power. After the zombie is dead, the update score will update the score by 10, and the zombie for each of the zombie in the loop will deduct by 1. As for attack in zombie, each zombie will take turn using the loop, and if the zombie health is more than 0, then it will damage the player with the zombie attack power. As for boss, it attacks the player with normal attack when the current round is less than the rampage round. If the rampage round is more than the current round, then it will enter a rampage mode where you will have 3 turns before the boss blow you in 1 KO hit. This code defines a function for a templated player class to manage weapon using an hash table. The name add weapon function adds a weapon to the player inventory by storing it to the map with its name as the key and print a confirmation message showing the weapon name and attack power. It also updates the player attack power based on the newly added weapon. The display weapon function lists all the weapon in the player's inventory, printing their name and attack power. If no weapon are present, it displays an appropriate message together. This function facilitates adding and viewing weapon for the player. Coming to the next code, this code defines a weapon menu function for a templated game class that allows the player to choose weapon from menu. The available weapon along with their attack power are stored in a hash table, which is called an order map, with integer keys. The menu prompts the player to select a weapon by pressing 1, 2, 3. The function validates user input to ensure it is an integer within allowed range, clearing and ignoring invalid input if necessary. Upon valid selection, it retrieves the corresponding weapon's name and attack power, creates a new weapon object, and adds it to the player's inventory using fplayer.addWeapon function. The loop exits after successful weapon choice. As you can see, there's an auto keyword. It lets the compiler automatically deduce the type of a variable based on its initializer. This reduces verbosity and simplifies code, especially when dealing with complex type like pair and tuple. Next, I'll start off with hash table, which is part of composite data structure. Hash table is very beneficial for me because hash table provide a fast lookup by using keys. For example, weapon name to index value such as weapon object, making it ideal for rapid weapon selection and switching. So here's the hash table diagram, which has keys and value. The keys comprise of all three weapons, and the value is the pointer to each weapon. So here's the diagram of the hash table also. This is the function, this is the key bind to the value. Continue off with single linked list. I've implemented skill chaining system in single linked list. It's beneficial because it allows for efficient traversal and addition to the end of the list, which is perfect for a skill chaining system. When user just started the game, the pointer will point to the null node because there's no skill selected. When user chooses the first skill, which is like Molotov, Frostbomb, or any other skill, it will be added into the chain of the single linked list and an arrow pointing to null. This process happens repeatedly when user is asked to change skill once the stage is clear. Here's the skill menu where user is prompted to choose among three survival skill: Molotov Cocktail, Frostbomb, and Adrenaline Injection. The chosen skill will create a class of the respective skill selected. Once skill is selected, then it will be added into the chain by using add skill to chain method. This method will check if there is no skill selected in the chain, then it will add the new skill as the first node. If user has selected new skill before, then it will traverse to the end of the chain to add the new skill. This line of the code create a pointer called current skill to keep track of the current node while traversing. Once at the end, this line of the code sets the next pointer of the last node to a new skill variable, effectively adding it to the end. Next will be a doubly linked list. Doubly linked list is beneficial because it provides flexible bidirectional data transversal, fitting inventory management and story progression. Well, each node to pointer next and previous facilitate efficient insertion, deletion, and movement in both directions, unlike singly linked list, which lack reverse traversal capability. The doubly linked list implemented in story opening for user to go front and back throughout the process, and inventory class also implemented in doubly linked list to allow access through each item bidirectionally. In this diagram, the chaining system is similar to singly linked list, just that there are two arrows pointing both sides of which user can access the previous and next node. In this provided code, defines the function for managing an inventory class that operates as a double linked list of item object. The add item function adds a new item to the node at the end of the list, updating pointer accordingly, making new item either the head and tail if the list was empty, or linking it to existing tail otherwise. The remove item function traverses the list to find an item by the name, and if found, remove it and adjusting pointer of its neighboring nodes to maintain list integrity. It handles scenarios where the item is at the head, tail, or in the middle, ensuring proper pointer update and memory cleanup. This code defines a story double linked list class that manages paragraph as nodes in a double linked list, using special boundary nodes called nil, which is a sentinel node to represent the empty state. It supports adding new paragraph to the end of the list, displaying the current paragraph, and navigating between paragraphs with functions to move to the next or previous paragraph. It includes function to check if the list is empty, reset the position to the start and determine if the current position is at the start or at the end of the list. The disruptor ensures all dynamically allocated nodes are properly deleted. This is a function called display horror story, which is located in game.cpp. All the storyline is being added into the W link list in a chaining system. User can just use next or previous to see the storyline. Next will be the stack concept, which is part of abstract data type. The stack's last in first out nature is ideal for undo functionalities. Ensure the most recent state is the first to be reverted. Each game state push ensure an accurate and orderly undo process. For example, each game state is safe, where the last game step is pushed and the last game step will also be popped, which is called last in first out nature. This code represents the structure of the game state that will be saved every time the player does an action. So the state that will be saved are player health, player score, zombies, remaining zombies, skill cooldown, boss, the boss rampage counter, rampage round remaining, and boss appear boolean. And it applies the push and pop function, which is a must use function in stack. So in this code called save current state, it will save the player health and other value in a file called gamestat.date. So every time when it is saved, it will represent this one. So let's say if the player does the first action, then it will be the gamestat1. Second action will be gamestat2. And third will be gamestat3. If a player wants to undo the last action, then it will pop the gamestat3. And the undo last stat function is used here for the undo functionality. Next concept will be the queue. Queue is used to manage player action and game stages using first in, first out queue. Events such as round started, game over are processed in order they are added, ensuring sequential event handling. So as you can see in this diagram, all the three events are in queue and the first event will be the queue first. So let's say if this is 10, 20, and 30, the concept of first in, first out means that the first element of 10 will be DQ and be used. In this code provided is used to implement queue concept. For example, NQ is put the event into the queue and DQ is used to obtain the event from the first object. So in this context of this code, the queue refers to F event queue, which is used to manage game event in a structured sequential manner. The queue stores events that the game process one by one in a first in, first out order. The function process event from queue continuously dequeues and process each event using F event queue and dot queue dequeue event, allowing the game to respond to specific event like round started, stage clear, game over, and quick game. This approach ensures that events are handled systematically, making it easier to manage game state, transition, player interaction, and other gameplay related logic in a consistent and controlled way. So here's an example of output. This is round started event, which is where it is the queue, and after you clear the stage, then it will enqueue the stage clear in the from the queue. Next, I will be continuing with binary tree. The binary tree is used to adjust game difficulty dynamically using binary tree structure. After stage completion, the player select one of two path nodes with a randomized boss appearance. So from this binary tree structure, the first stage will be zombie, then boss, which you attack the zombie first, then you will proceed to the boss. Then the binary tree, the node of the binary tree will be then branching out to zombie, then boss, or boss. This structure is very randomized because it's a 50-50 chance that this node you might meet with a boss or zombie, then boss, or this node same as the one that I said just now. This process will be repeated stages by stages until the player health is 0. In this code, the binary tree concept is used to represent and dynamically adjust the game's difficulty level as player score increases. Each difficulty stage is represented as a node in a binary tree, with the current difficulty node potentially expanding by attaching left and right child nodes to indicate branching path or stages as difficulty increases. When a certain score threshold is met, new difficulty nodes are attached as left and right children if they don't already exist. The player is then prompted to choose between two doors, with one potentially a boss enemy determined randomly. This structure allows the game to progressively increase complexity and provide branching path of difficulty with each node representing a unique stage. In the game difficulty progressive. So this is the binary tree class where left and right represent the binary tree of the left node and right node, and this one is the attaching the node to the binary tree node. So once you clear the first stage and other stages, you will be prompted to choose between door 1 and door 2, which is a randomized structure. Either you attack the boss, then go to the attack the zombie, then go to the boss, or directly attack the boss. Next is my design pattern, which are design pattern that cover iterator and command pattern. Let me proceed with iterator first. The use of iterator is implemented in my doubly linked list iterator class to standardize traversal decoupling iteration logic from the list structure. In this code, the doubly linked list iterator class is an iterator for traversing a doubly linked list, enabling bidirectional traversal through nodes. It keeps track of its current position using a pointer f current to the node. The iterators provide overloaded operator to move forward, such as plus plus and backward minus minus through the list, either as pre-increment or decrement, modifying the iterator before returning, or maybe a pause increment and decrement modifying after returning a copy. It also supports comparison operators such as equal and not equal to check equality with other iterators, as well as dereferencing a pointer to access the value of the current node. This iterator facilitates standard list traversal and access pattern commonly used in iterating through collection. As we can see here, there's a special function that has a T here. In this function, the signature T operator function, the T represents the return type of the operator function, indicating that the dereference operation pointer will return a value type of T. This T is a template parameter for the doubly-linked list iterator class, meaning it can represent any data type such as integer, boolean, string, that the list and iterator are templated to work with. Next is my last concept, which is my research concept called command pattern design. The command pattern encapsulates action, offering flexibility and decoupling execution from action logic. From this diagram, this is part of the command pattern design. This is the invoker class and with two concrete command class, attack command and skill command. Attack command is typically used by zombie boss and player because they have an attack function, and skill commands is only used for player because only player has a skill. So in this provided code, demonstrate the use of command pattern through a game invoker class and two concrete command class called attack command and skill command. The game invoker class holds a reference to a command object and trigger its execution via execute command without needing to know its detail, adhering to the principle of decoupling. Attack command and skill command encapsulate specific behavior such as attacking or using skills on a player object and execute this action with when their execute method is called. This pattern allows for flexible behavior modification, adding new commands and maintaining a clean separation between commands triggering and the operation themselves. In this code, in this specific three column of code, after the current state is safe, then it will create an attack command using make unique to encapsulate the attack action, passing in relevant context such as player, target, which may refer to zombie and boss, and the remaining zombie, and whether a boss has appeared or not. This command is set as the current command for the invoker using set command and is then executed with execute command, triggering the specific logic of the attack command. This approach allows for encapsulated, flexible, and decoupled management of a game action through the command pattern. So this is the output for attack command, and this is the output for skill command. For the last part of my presentation, I will do some reflection upon what I've learned from the project. Reflecting on the development process, and awareness and understanding of data structure proved to be crucial. Each data structure used, whether arrays, linked lists, stacks, queues, or trees, brought unique advantages tailored to different components of the project. For instance, queue effectively managed event processing while linked list facilitated dynamic inventory system. Using appropriate data structure allow for optimized memory usage, faster operation, and more maintainable code. However, challenges emerge particularly in choosing the most efficient data structure for specific tasks and managing edge cases such as memory leaks with dynamic memory allocation. For further improvement, focusing on optimizing data structure choices based on real-time performance profiling would be beneficial. Enhancing the code base with more advanced structures such as balanced trees or hash maps could improve the efficiency of operation like searching and sorting. Furthermore, incorporating modern C++ features such as smart pointers and containers from the standard template library STL would help ensure better memory management and reduce potential bugs related to manual memory handling. Continuous learning and exploration of data structure will be the key to further improving the robustness and efficiency of the development process. That's all for my presentation. Thank you.